hybrid AI approach solves problems in tractography for brain surgery. Okay, this sounds fascinating. What is tractography and why is it important? The brain is a highly complex network of nerves, cells, interconnected by delicate pathways known as nerve fibers or tracts. These connections are essential for movement, speech, thought, and many other functions. To visualize these structures, researchers use tractography, an image technique that calculates the course of nerve pathways on specialized MRI scans. This information is particularly crucial for planning brain surgeries, such as those performed on epilepsy patients undergoing surgical intervention. Okay, that's very interesting, and that's a good technology to have that we currently have. Current tractography methods rely on mathematical models that infer the location of nerve pathways from MRI data. However, these methods often involve uncertainties, especially when the brain has been altered due to disease or surgery. This is where modern AI methods come into play. By leveraging machine learning, these systems can recognize patterns and generate more accurate reconstructions. Ah, that's cool. See, and this is where AI is going to really advance us. And I have heard this before. In the medical field, we're going to advance a lot more than we had in previous years and a lot faster. This is going to be rapid advancements in the medical stream. And it's crazy because it's all data and it can just pick up that data from anywhere and figure it all out by grabbing that information, where us as humans find it a bit harder to be able to put all these things together because there's so much information. So this is going to be very interesting in the next 5, 10, 15 years to see what happens in the field of medical science and everything else. I'm looking forward to potentially living longer. That's cool. AI-powered tractography shows potential, but also challenges. In the study, the researchers tested a widely used AI method called TRACSEG, originally trained on healthy brains. The team investigated whether it could also work for epilepsy patients who had undergone, I'm going to try to say this word, hemispherotomy, a surgical procedure that disconnects the two hemispheres of the brain. Wow, it's crazy. The results shown in that TRACSEG performed well in many cases, but also produced unexpected errors. That's very typical of AI. But it's still good because these errors will only improve and the errors will reduce. It's just like these learning language models. Like in the beginning, there was a lot of errors. Now, the current versions that are out, there's very minor errors, and the errors are reducing more and more. There's becoming less and less errors. So, although it's probably a bit of a downside at the moment, it will only get better, and there will only be less errors as we move through time. It reconstructed nerve pathways that should no longer exist due to the surgery. Okay. The phenomenon known as hallucination. And there you go. That's what AI does. It hallucinates. When the AI systems first came out, not first came out, but a couple of years ago, I remember asking them a question about a certain boxing fight, and it just completely fabricated what actually happened in history. And it made out that someone else had won the fight. and it just gave some crazy story about how the fight played out and how the other person won, when in actual fact, that was not true. So these hallucinations do occur, and they're kind of funky sometimes. At the same time, some remaining pathways were either incompletely captured or entirely missing from the reconstruction. Okay. A new hybrid approach for more accurate reconstructions. Yes, that's what you need, a hybrid approach. AI as well as human intervention. But also, learning models is the way to go as well. Being able to train it and having a system that can identify when it is incorrect, and then it learns from there and where it went wrong and why it went, or why it chose that result. To address these issues, the team developed a new hybrid method that combines the advantages of AI with the data fidelity of traditional techniques. This approach ensures that only existing nerve connections are reconstructed. The result? No more hallucinations, better detection of preserved pathways, and overall more accurate reconstructions, even in healthy brains. See, there you go. You just got to figure out how you can stop these hallucinations and how you can make it more accurate. Proof. Dr. Thomas Schultz, principal investigator in the life sciences at Lamar Institute and a professor at the Institute of Computer Science at the University of Bonn, highlights the significance of this work. Our study demonstrates both the potential and the limitations of AI-powered tractography in clinical applications. Combining AI with traditional methods offers a promising solution for more precise reconstructions, especially when dealing with patient data affected by pathological changes. Our goal is to further refine these approaches and make them applicable for neurosurgeons in the long run. Yeah, so that's crazy. We are living in the future. Okay, last little bit. Founded by a TRA or TRA, I don't know, a TRA research award from the University of Bonn. This publication is the result of a collaboration funded by the Modeling for Life and Health Research awarded from the University of Bonn's Transdisciplinary Research Areas, okay, TRA, Modeling and Life and Health. The project was conducted in partnership with blah, 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 blah. Okay, this just is giving a shout out to the researchers, basically. But anyway, this is very promising for brain surgery, brain surgeons, and humans in general. Humans with issues like epilepsy, or who knows how far you can go with this sort of technology, what you can do with it in terms of mapping the brain out and other issues with the brain. So this is very promising. Anyway, just came across this article and thought it might be interesting. See ya.